Welcome to this expert-level training module on implementing generative AI applications. Today, our primary focus is exploring exactly how to deploy a model and interact with it directly within the Microsoft Foundry portal. Welcome to this expert-level training module on implementing generative AI applications. Today, our primary focus is exploring exactly how to deploy a model and interact with it directly within the Microsoft Foundry portal. Before we deploy any models, we must first understand the foundational architecture of the platform itself. Microsoft Foundry is an enterprise-grade platform as a service designed explicitly for building, deploying, and managing advanced artificial intelligence applications and agents securely on Azure. To begin your development journey, you must initially provision a Foundry resource. A Foundry resource serves as the overarching Azure cloud resource that provides access to the underlying platform capabilities. This includes hosting for large language models, access to the agent service, deployment governance, operational quotas, and robust security boundaries. However, you do not build your applications directly at the resource level. Instead, you create a Foundry project. A Foundry project is a dedicated, highly secure workspace located inside your Foundry resource. Within this workspace, your engineering teams can collaboratively build AI agents, manage files and datasets, establish vector search indexes, and define project-specific settings. A single organizational Foundry resource can house dozens of independent projects, each dedicated to a distinct enterprise use case. When you navigate to the Microsoft Foundry portal, you will encounter a modern web-based interface that centralizes all of these development activities. The portal features a new user interface specifically designed to offer a seamless experience that combines absolute simplicity with incredibly powerful tools, enabling developers to rapidly build and scale multi-agent applications. Understanding this hierarchy from the cloud resource down to the secure project workspace is the absolute first step in deploying AI. As an enterprise architect, mastering this portal environment empowers you to orchestrate complex artificial intelligence workflows while strictly maintaining corporate governance and continuous observability. Foundry resources and projects can be deployed manually through the Azure portal user interface or programmatically using infrastructure as code templates, which is the recommended approach for automated, repeatable enterprise cloud deployments. This diagram illustrates the Foundry architectural hierarchy. Once your Foundry project is successfully established, the very next step in the deployment process is selecting the appropriate foundation model. To accomplish this, developers utilize the Foundry Model Catalog. The Model Catalog is a unified, central hub designed specifically for discovering, evaluating, and ultimately using a vast selection of generative AI models, sourced from an extensive range of industry-leading providers. Within this rich catalog, you will find thousands of models organized into distinct model families. A model family groups together related models that share the exact same underlying architecture but differ significantly in their overall size, specialization, or version number. For example, you can explore Microsoft's proprietary models alongside the highly advanced GPT-5 family, Anthropic's Claude Opus 4.5, and open-weight alternatives like Mistral Large 3 or Meta Llama. To ensure you select the absolute perfect engine for your specific business workload, the catalog provides granular filtering capabilities. You can seamlessly filter this massive list by supported inference tasks, foundational capabilities like text generation or multimodal image reasoning, and specific provider sources. Furthermore, the catalog explicitly includes vital documentation for every model, such as benchmark performance results, and comprehensive responsible AI model cards that transparently outline known constraints, limitations, and safety caveats. The Foundry portal even features global model leaderboards that actively rank these foundation models based on critical attributes like raw quality, safety, and inference throughput. If you require assistance navigating this vast catalog, the portal provides a built-in AI helper known as Ask AI. This specialized agent can expertly guide you through the documentation, compare model capabilities, and help you finalize your selection before initiating a deployment. Selecting the correct model based on empirical benchmarks guarantees your application will perform optimally while adhering to budgetary requirements. While there is no application code required to browse the catalog, identifying the precise model identifier string within the catalog documentation is essential, as this exact string will be required later when invoking the model via backend HTTP requests. Observe the model selection workflow. After identifying the perfect foundation model within the catalog, you must formally deploy it into your project workspace. It is critical to understand that a model residing in the catalog is merely raw computational potential. Deploying a model in Microsoft Foundry takes that raw AI model and actively makes it available for use in production through a highly stable, scalable, and secure application programming interface endpoint. This deployment process effectively turns the algorithmic model into a living service that your client applications can reliably call over the internet. When initiating a deployment in the Foundry portal, you are required to customize several vital operational parameters. First, you must explicitly define the deployment type. Foundry offers flexible deployment mechanisms, such as standard deployments for real-time synchronous chat workloads, global batch deployments for asynchronous data processing at scale, or regional provisioned throughput for guaranteed, dedicated performance without noisy neighbors. Next, you must define the exact model version and configure your rate limits, specifically the tokens per minute, or TPM threshold. A token is the absolute smallest unit of text or data that the generative AI model can process. By setting a strict TPM limit, you proactively govern the maximum computational volume your deployment is allowed to process within a 60-second window. This is an absolutely mandatory architectural step for enforcing financial cost controls and preventing malicious abuse or accidental runaway application loops from overwhelming your Azure environment. A properly configured deployment ensures consistent inference performance, unshakable reliability, and strict enterprise governance, allowing developers to safely expose powerful generative AI capabilities to their downstream software applications and autonomous agents. Mastering these parameters allows architects to balance dynamic application performance against strict infrastructural budgets and stringent security requirements. Configuring TPM limits ensures backend stability. When an application script exceeds this deployed limit, the Azure endpoint intentionally returns an HTTP 429 error. Client code must implement asynchronous retry logic to securely catch this exception and delay subsequent executions. This flowchart maps the deployment parameter configuration. We take the selected catalog model and initiate portal deployment. To truly appreciate the power of the Microsoft Foundry portal, we must examine the automated deployment lifecycle that occurs under the hood once you finalize your parameters. When you click Deploy, Foundry dynamically orchestrates a massive array of cloud infrastructure entirely behind the scenes. First, immense compute resources are automatically allocated. Foundry assigns the specialized hardware strictly needed to run the complex neural network, provisioning the necessary CPUs, GPUs, memory, and networking paths required for enterprise-scale inference. Simultaneously, a unique, secure API endpoint is generated. This endpoint acts as the permanent HTTP address for your AI service, allowing your applications to securely invoke the model through the OpenAI Responses API. This endpoint is fiercely protected and validated through strict Azure Management API checks. Third, your precise configuration is permanently locked in. The specific model version you selected, along with mandatory responsible AI safety settings and content filters, are bound to this deployment instance, guaranteeing that the model's behavior remains completely predictable and will not silently drift over time. Finally, the instant the deployment completes, comprehensive monitoring and logging mechanisms become completely active. The Azure infrastructure begins relentlessly tracking all vital usage metrics, including raw inference performance, network latency, API errors, and real-time financial costs. This telemetry provides critical observability, enabling operations teams to continuously evaluate the health and efficiency of the AI system. The Foundry portal abstracts this monumental infrastructural complexity, allowing AI engineers to launch production-ready generative services in mere minutes rather than weeks. Understanding this fully automated lifecycle proves that deploying a model in Foundry is not just changing a software setting, it is dynamically orchestrating a highly secure, enterprise-grade cloud ecosystem. Although the deployment lifecycle is fully managed by Azure, infrastructure developers can programmatically verify its completion by executing GET requests against the Resource Manager API, parsing the JSON state payload to confirm the provisioning status reads as successfully completed. This visual walks through the automated infrastructure lifecycle. Triggering a deployment commands Azure to allocate GPU compute. Once your generative AI model is successfully deployed and its endpoint is active, the absolute best way to interact with it is through the model playground located directly within the Microsoft Foundry portal. The Foundry Playground provides a highly interactive, web-based chat interface that allows developers, prompt engineers, and business stakeholders to actively test the deployed model without needing to write a single line of application code. In the playground, you can submit natural language user prompts and immediately observe the completions generated by the model. This is an absolutely critical phase in the development lifecycle, because generative models calculate responses probabilistically. Therefore, you must empirically validate that the model truly understands your domain-specific language and formatting requirements. The playground allows you to experiment relentlessly with different phrasing, context injection, and few-shot examples to achieve the perfect output. Furthermore, the portal enables you to test different models side by side. If you are unsure whether your workload requires the massive reasoning power of the GPT-5 family or the cost-efficient speed of Mistral Large 3, you can deploy both, load them into the playground, and directly compare their responses, latency, and tone using the exact same prompts. This rapid, interactive experimentation loop drastically accelerates development. You can refine your AI agent's conversational behavior, validate its ability to summarize complex documents, and ensure it safely handles edge case user inputs. By thoroughly vetting the model's performance in the Foundry Playground, you guarantee that it will behave exactly as expected when you ultimately transition the system into your live, production-facing client application. The playground is the ultimate sandbox for refining artificial intelligence, turning abstract theoretical capabilities into proven, highly reliable software behaviors. The playground eliminates the immediate need to configure Python environments or local.env variable files. It automatically handles the cryptographic token passing in the browser, empowering data scientists to focus exclusively on refining conversational semantics. Here we map the interactive testing loop. Using an active model deployment, we open the Foundry playground and submit prompts. We rigorously evaluate model completions. If the output fails expectations, we iterate. While testing prompts in the Foundry playground, you also have the ability to explicitly configure several critical model parameters that drastically influence the engine's runtime behavior, inference performance, and financial cost. First and foremost, you must configure the system instructions. The system prompt is an overarching instruction set that permanently defines the model's behavior, its professional tone, and its strict operational guardrails. For example, you might define the system instructions as, "You are a highly helpful scheduling assistant who returns answers strictly in concise bullet points." This is fundamentally different from the user prompt, which is the dynamic, real-time question submitted by the human user via the chat interface. The model mathematically balances the dynamic user input while strictly obeying your system instructions. Next, you must adjust the temperature parameter. The temperature dial mathematically controls the model's strict balance between creative output and rigid determinism. A low temperature forces the model to consistently select the highest probability words, which is absolutely ideal for highly analytical, factual tasks like extracting financial data. Conversely, a high temperature encourages the model to use more diverse vocabulary, making it perfect for creative writing or marketing copy. Finally, you can set the max output tokens parameter. This explicitly caps the maximum length of the response the model is permitted to generate for a single prompt, allowing you to actively control token consumption and dictate throttling behavior. By meticulously tuning these system instructions, temperature settings, and token limits inside the visual playground, you capture the absolute perfect working configuration for your enterprise. These precise configurations ensure your AI agent operates safely, cost-effectively, and perfectly aligned with your business goals. These exact parameters directly correlate to attributes within the API request payload. The system instructions are parsed as a system role dictionary within the messages array, while temperature and max output tokens act as standalone numeric float and integer parameters alongside the array. This diagram illustrates how parameters influence execution. From the playground UI configuration, developers define parameters by setting system instructions, adjusting the temperature dial, and capping tokens. In our final section, we explore how to transition your perfectly engineered parameters from the Foundry portal directly into your production application code. A client application is the custom software program, such as a mobile app or a secure web dashboard, that your users will actually interact with. To connect this client to your deployed model, your code must utilize the Microsoft Foundry SDK and the underlying OpenAI Compatible Responses API. When you are ready to write code, the Foundry Playground provides a phenomenal shortcut. You can simply click the View Code button within the interface. This feature instantly generates the exact Python or QRL payload, reflecting all of your current UI configurations, including your finely tuned system instructions, temperature settings, and target deployment name. To successfully execute this programmatic connection, your application requires 3 critical pieces of configuration data retrieved from the Foundry portal: the secure endpoint URI, the cryptographic API key or Microsoft Entra ID credentials, and the specific model deployment name. Your client application code dynamically formats the user's input, bundles it with the system instructions into a structured JSON payload, and transmits it via a REST HTTP request securely to the Azure Cloud endpoint. The server processes the inference and returns the final generated text or multimodal analysis back to your client. Thank you for joining this expert technical deep dive on deploying and interacting with models in the Microsoft Foundry portal. Please be sure to like this video, subscribe to our channel, and share this knowledge. To accelerate your career and master these advanced cloud AI workloads, visit quicktechie.com for premium certification prep, featuring extensive Q&A banks, ebooks, audiobooks, and expert interview guides. Build intelligently, keep building securely, and we will see you in the next lesson. To maintain architectural security, production code must never hard-code the extracted API keys directly into the script. Developers must utilize local.env files and libraries like os.getenv in Python, ensuring cryptographic secrets remain secure during GitHub repository commits. Our final diagram charts the transition to code. Taking validated playground settings, developers click View Code to retrieve the endpoint URI and credentials.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. If you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.